Everyone, I'm just getting things set up so that we can start this part 2 of our video lessons that we've been working on. So we've been working on normal distribution from section 5.4, and this is the second half or the last half of that particular lesson. In this lesson, certainly in the first part, we determined the properties of a normal distribution so that you understood what we mean by the term normal distribution and what you can expect from it. And then the second part of the objective was to compare normally distributed data. And that's what we'll be focusing on a little bit in this lesson. So as we start to work with some raw data sets, it's important that you keep in mind a few things about them. Keep in mind that when you're working with a raw data set, that your sample size will absolutely determine how clearly you see the normal distribution. In fact, it's said that if you need a sample size of roughly 100 samples before you really will get a rough idea of the normal curve. So if you think back to the example we did with DICE, where you did 50 data terms, you'll remember that your graph was kind of rough. I mean, it had the shadows of looking like a normal curve, but it still had a long ways to go. Whereas when we used a DICE simulator and started to increase the numbers of data sets that we had, then the graph became more and more recognizable. So the sample size definitely affects what you see. So we're going to take a look at an example where they are asking you to evaluate whether or not this particular situation seems to be distributed normally or not. So in taking a look at the text of the question, you can see that it's called the Census at School project. They've collected data from classes around the world, and this is a random sample for 93 Canadian male students. So there's a frequency table that came along with it too, which we'll look at in a minute, and it is talking about the heights of students. And it starts by giving you the following details. The median is 175, the mode is 176, and the mean is 174 and a quarter, more or less. It does tell us that the standard deviation is 9.35, which is fairly large for a standard deviation. Now, if we look at these three terms of central tendencies, the mean, median, and mode, we see that these numbers are really quite close together. 175 is very close to 174 and a quarter, and it's not that far from 176. And so the position of these measures of central tendency being so close together gives us the first indication that the data set we're looking at is probably normally distributed. So then they asked us to look at the frequency table. Now, when you glance at the frequency table, you see some values in the center that are definitely high, some medium ones on the sides, and then some very low ones in the beginning. It does have some irregular patterns to it, but it does seem to suggest that it could be normally distributed. And so we're going to take a closer look at that and kind of give a little bit more support to our idea that this may be a normal distribution function. So we're going to take a look, first of all, at what the actual intervals should look like. We know that our mean is 174.25, and that, if I look back at the question, let me see if I can find it. So the mean is 174.24, and the standard deviation is 9.35. Okay, so let's go back here. So 174 this should be 24. It's funny, I've said 0.25 so often that I actually believed it. So I've written it down a hundredth off there. We take this 174.25 and then we find the standard deviations using the values that we were given. And we get the following numbers that are significant numbers for what we're doing. So what we're going to look is take a look at the two values in here. This would be 34 and 34%. And we're going to look on the graph. So it's going to go from 164.9 to 183.6. And that takes in all four of these plots of numbers. Goes right to 165, I guess is where it was. And then it goes up to 185. That's a little further than what we need to go. So when we add this up and find that it is 65 out of 93, we know it's a little bit less, which is looking very hopeful that the two middle terms are pretty close to 68%. Oh, sorry, and then we need to do the middle four bins or sections. And so what we're going to do is include everything up to 2 standard deviations. And that means we're going to add in this guy and this guy, which gives us 90 out of 93. And that one, when you look at how far we want to go, like we went too far here, so it's a little lower than that. So When it comes in at 97%, it's not a stretch to think that, it could have been a little lower at 95%. So what we would say is that the middle two terms and the middle four terms seem to indicate that this data is normally distributed. The last thing they ask you to have a look at is the histogram and to see if you see any patterns that remind you of the normal curve. And sure enough, you have the values that are low on the edges, gradually getting higher and then back down again. So while it's a primitive example, it definitely is an example of normal distribution. Okay. So the next question we have is very similar to the one we've just done, except you have to get the information organized. So you have to take all these values and put them in the calculator, calculating the mean, the mode, the median, and the standard deviation. So the question is, does it actually approximate a normal distribution? So the first thing we're going to do is find the mean and the standard deviation and the median. We see that these numbers are really quite close, so they're following that. We put our numbers on a number line so we can get a sense of it and realize that if we're going to be looking, we need to try and set up something that gives us the following spaces. And so we're going to use the interval from here to here and here to here and so on, going and collecting all the numbers that we have. And using a frequency table and a set of tally marks, we are finding that the following frequencies are coming out over on the side. So if we analyze this a little closer and look at the middle two, we have 35 out of 50, which is approximately 70%. So that means we're looking at pretty close to 68. And then the middle four, where we're going to add on this one and this one, we're getting 48 out of 50, which is 96. And again, very close to the standard distribution graph. So once you have this in place, the question is, what is the likelihood that the cell phone will last for more than 3 years? Now, what I'm going to do is go back to the diagram I created right here. More than 3 years would be from this point forward. That's 13.5 plus 2.35 plus 0.15. A total of, sorry, I've just blanked out because I've been on another planet. A total of 16%. Okay, sounds good. So in other words, what is the likelihood that the cell phone will last for more than 3 years? About 16% chance that it will do that. There it is, written out so we can see it. Okay, there you have it. Those are the objectives of taking a look at the normal distribution properties and then comparing normally distributed data. Okay, have a good class, everybody. Now, I don't know, no, it doesn't look like I included the homework assignment, so you'll have to refer to Google Classroom for that one. Good luck, everyone.